Alright class, in this video we are doing Learning Outcome 20 for Math 2015. In this learning outcome we are going to extend our fraction operation and understanding to work with rational expressions. The first problem that we'll do as an example of extending our fraction knowledge operations is addition and subtraction of fractions. But with these fractions, they're special because they have variables in the problem. So we have terms in the problem. Numerators and denominators have variables in them. But it is great because the conceptual understanding of fraction, addition, and subtraction can extend to variables. If we don't know what a number is on the numerator or denominator, we can still work with it. So it's a wonderful thing. First, when we're going to add y squared over b plus 9 over 5, and then subtract 9b over 5b, we're going to do this problem in two steps. So we'll go ahead and do it from left to right, and that we're going to take care of that y squared b over b plus 9/5 first. Okay. When we're adding fractions together, we need to get a common denominator first. Now, usually the denominators are numbers, but here we have a variable in the denominator. When we have regular numbers, say we want to find a common denominator between 2 and 3. Okay, we list the multiples of each number, 2, 4, 6, and so on. For 3, we can list 3 and 6, and then we stop when we have a common denominator right here. But here we have b and 5. So the common denominator will be at least, I should say can be, at least the product of the two denominators. There are denominators that are in common but that are smaller than the product, but at least we know that we can use the product of the two denominators to find it, as in this case of 2 times 3 is 6. So sometimes when you work with just numbers, it is more efficient to use the least common denominator, meaning that you'll have smaller numbers. But you can always use the product of the denominators. And that plays out true more for the case of rational expressions, rational numbers, which means is a fraction with a variable in it. Okay? So we're going to get a common denominator in this problem. We need to put everything under the product of the two numbers. And I'm doing 5 times b because instead of b times 5, because it's traditional to put the number first and then the variable second in the way we structure our algebraic terms. So we have two fractions that have 5b as the denominator. Now, to see what the new numerator is, we investigate what happens at each denominator, see what you need to multiply by to get to the new denominator. And that's the same thing that you multiply the numerator by to get the new numerator. So the difference between this one and this one is that b was multiplied by 5. Okay, so we're going to put like a times 5 here. Now, that's what I need to do to the numerator. Put a times 5 there. And when we do that, we're going to find that we have 5y squared. Okay. Now let's look at the difference between the second fraction in our addition problem with the denominators. 5 became 5b. So what it does is multiply by b in the denominator. I need to do the same thing for the numerator to maintain equality. The equivalent fraction, 9 times b is 9b. Okay. And so what we have is we have 5y squared plus 9b divided by 5b, 9b over 5b. So 5y squared over 5b plus 9b over 5b. The algorithm for adding fractions dictates that the next step is to add the numerators and keep the denominator the same. Now I can't combine these into a single number, but I can still combine them together. Oops. And put a 5b here at as the denominator. And since that is, and then we check for simplification, but that's all the simplification we can get because there's nothing that can go into the numerator and the denominator that's the same. Okay, so we've completed our first step of this problem. So this first step is add. The second step is to subtract. So we'll put that over here. What we're going to subtract is whatever our sum was. So I'll copy that down. 5y squared plus 9b divided by 5b. And I'm going to subtract off 9b over 5b. Okay. If you notice, we are subtracting a fraction that is not in simplest form, lowest terms, but it's okay. We are actually grateful because they have taken care of the common denominator part for us, which means that the fractions already have a common denominator, and we're going to go ahead and subtract them, the numerators. So we have 5y squared plus 9b, subtract 9b, all over 5b. Since the denominators were the same, we're going to keep that same throughout. Now simplifying in the numerator, notice that we have two opposite expressions. We have plus 9b and minus 9b. And what we do, those will cancel out because I have a positive 9 and a negative 9. So think about 9b length sticks or tiles. Positive 9 of them will cancel with negative 9 of them, make 0 pairs. And when they do that, we get 5y squared over 5b. Now let's check if our answer is in simplest form. Can we simplify our fraction even more by factoring out the same thing from the numerator and denominator? I'm actually going to be more explicit with this factoring instead of just like canceling out, because what we're doing is we're going to use this in our division and multiplication of rational expressions or the fractions with variables in them. So we're going to separate off our 5 over 5, make that 1, and then that will become just y squared over b because of the identity property. Okay. And so our answer is y squared over b. So that's how we add and subtract. You get a common denominator, add or subtract the numerators. Moving on to this next one, we have y squared over b times 9b plus 5 over 5 plus y. When you multiply any fraction, the algorithm says that we are going to multiply the numerators and multiply the denominators, and that's true for this case. So I'm going to go ahead and just put equals 9 squared times 9b, y squared times 9b over b times 5 plus y. Okay, I put the quantity 5 plus y there. So you multiply the numerators and denominators. That's step 1. I'm going to write these steps down so you can remember. So we multiply the numerators and denominators. The next step is that we're going to simplify. We need to factor everything. Okay. And we might need to use the commutative property to help us. Okay. So we're going to use the commutative property. Can switch around the factors. use the commutative property and factor any whole numbers. When we split up all of our terms into factors, then we can see where we can eliminate variables or numbers from the numerator and denominator. So what I have is a 9 times a b times y squared. Okay, so I've factored that. And that's over a b times 5 plus y. Now 5 plus y can't be factored into 5 and y because it's just addition. Okay. Now what we're going to do is we're going to separate the factors that divide to 1. Just like we did in the other problem. So I notice that I have a b and a b in the numerator and denominator, and that's all that's in common between the numerator and denominator. Okay, the y I can't get to because it's squared and it's also added to 5. Okay, so I can't do anything with the simplifying those two. That's bundled up into the y squared, which is y times y. Okay, you can do things with that one, but what's tied to the y in the denominator is the plus 5, and when that's tied there, we can't operate on it unless we have another term exactly like it where it is also y plus 5. Okay. So the only factors I can separate out are the b, put them in front, b times 9y squared over b times 5 plus y. Okay. So next, after that, we're going to divide to make 1. Okay, so we'll continue up here. I'm going to divide out, separate off the b over b. Pull it off there, 9y squared over 5 plus y. Okay, so I'm dividing this to make 1 times 9y squared, 5 plus y. Identity property of multiplication. To show that 1 times anything is itself. So what we have is a simpler expression. Okay. And there we are finished with our product. We can't simplify anymore on the numerator or denominator. In our last part of this lesson, we're going to look at a rational expression or fraction with variables in it of division. Okay. And we are only going to necessarily draw on our knowledge of the algorithm of division. And multiplying the reciprocal is the procedure. And so that's sufficient for our needs for today. So what we're going to do is we're going to multiply by the reciprocal. First. Okay. And when we do that, we get this expression here. So the first fraction will stay the same. We'll do y plus 5 in the denominator times y minus 5. And then that'll be under 3y squared. But I've changed it to multiplication, and since I'm in algebra mode, I'm going to use a dot for multiplication, as to not confuse the times sign with an x. And then the reciprocal means that I put the numerator in the second fraction into the denominator, and the denominator from the second fraction to the numerator. So that will be 5 plus y over 9y. Okay, multiplying the reciprocal. The next thing that we're going to do is we're going to multiply the numerators and denominators so that we have one fraction. When we do that, we're going to just write 3y squared times 5 plus y. And do that over y plus 5 times y minus 5 times 9y. Okay. So it's multiplying the numerators and denominators. Next, we'll separate the factors so we can see if we can do any type of canceling, as it were. But canceling is really taking out the factors and multiplying by a form of 1, and which becomes the identity, just like we did in the last problem. So we're going to do that again with the division, and we'll do it in steps instead of just crossing things out. Okay. So we're separating our factors. So I'm going to separate it into 3 times y times 5 plus y. Now 5 plus y is in parentheses, it's all together, that's just one factor. And that's over y plus 5 times y minus 5 times 9 times y. Okay? So we're separating our factors, and we're going to group them together into a way to make them divide out to 1. Anything that's in common, I'm going to use the commutative property. Okay, so we're going to go up here now. So we're going to use the commutative property to group factors in common in the numerator and denominator. Okay, so I'm going to put my 3 here times y times 5 plus y. Okay. Okay, well, let's take a look at what we got here. So this y, the second y here, doesn't need to go there, so we're going to kind of cross that out here and put it over here. Because on the denominator I have 3, this 9 becomes 3 times 3. Okay. Because I'll have a 3, and then I'll have a y, then a 5 plus y, and then I have my other 3 here and my y minus 5 still to do. Okay. So the ones that are in common here are 3 times y times 5 plus y. And notice that I had to break down the 9 into 3 times 3 as I was working through this. I'm going to separate those out. And the key is that that will go to 1, but I need to see what's left. So what's left in the numerator is y divided by 3 times y minus 5. Okay. So this one goes to 1, and I have y over 3 times y minus 5. Now we use the identity property. So here we divided to make 1. And then I'm going to use the identity property of multiplication so that I can do just 1 times anything is itself, right? Okay, and that's my answer here. Can't simplify anymore. Okay, so that's one example of each of the operations. In the homework, you'll be going over several examples of each and some with whole numbers. On Monday, since this is our second day, we will be going over the second part of this lesson, which will give some homework hints in a video. Okay, good luck, and let me know if you have any questions.